and welcome to Dudents and Clams. This is a Blender 3.4 tutorial on how to create geometry nodes to generate an arch stone bridge. The number of arches is selectable, as well as the shape of the top of the bridge, which can vary from flat to a smooth curve to a noticeable hump. The textures are exposed through the modifier properties for easy replacement. In addition to the basic construction of the bridge, two different important topics are covered in some detail. The first is how to procedurally unwrap curved shapes, such as the arches, so that the texture follows the geometry. The second is how to create an arbitrarily complex closed curve, such as the size of the bridge, so that they can be seamlessly textured. All of the textures for this are procedurally generated and are available in the project file, which is a bit of a funny or perhaps tragic story. I theoretically finished this project file 2 weeks ago. I'm ahead of schedule, I thought. I was going through the final stages of packing and testing when I noticed that the project file size was well north of a gigabyte when packed due to the 6 texture files I was using. This isn't a huge problem for local use, but for sharing content around the internet, it is a definite problem. I spent the last couple of weeks dramatically improving my procedural texture game. Now I have a couple of dozen new textures to use, and the project file shrank to a more manageable 3 megabytes. Thanks to Ryan King for his amazing videos on how to create procedural textures. The project file for this is available on Gumroad. Follow the link below. Let's do a quick tour of the interface. What I did for this project file is brought up about a dozen pictures of stone bridges of various ages and styles, and tried to come up with a way to create most of them. So, first thing was controlling the shape of the bridge. So, I wanted to be able to go flat, obviously. I wanted to go for like a garden bridge style with a hump, but also some bridges just have kind of a smooth curve shape. Like that. So I wanted that to be possible as well. And some bridges have there's a combo bridge slash forward, so they actually have a D curve in the middle of the bridge. So I actually allow the hump to go a bit negative to create that effect. And of course, the number of arches is selectable and the shape of the arch as well. So you can put any degree of circularity on that you want. Usually, brick textures are staggered like this because that's the natural shape of a brick wall. Some are more complex. But for the railing and the arches, it turns out that this staggering is not useful. As a matter of fact, it tends to destroy the even texturing of the arch. So in the procedural textures I generated specifically for the arches and the rails, I deliberately did not stagger the bricks, and it just helps them work much better for this project. That being said, let's dive in. First thing we need to do is make sure that Node Wrangler is enabled by checking Edit, Preferences, Add-ons, Node Wrangler. It is enabled. Now let's do some geometry nodes. We don't do anything with the default geometry, so let's kill that. What I do want is a line, and the length of this line will determine where we place the arches. I want to have the length of the bridge controlled by a different parameter because you might want to have the arches well set in from the bank, or you might want to have the last arch coincident with the end of the bridge, but I want that to be user input. So I'll go to the Group tab, create a new input. I'm going to create a lot of input, and every time I use the word arches, it's going to apply to the arches as a whole. And I'm also going to have some controls for each arch, but when I do that, it'll be singular. Let's give this a default of like 2. And when we do this, these same values show up in the attributes. And when I talk about the user interface, this is what I'm talking about, because this is where the user will go to control these values. For example, the arch's length. Okay. Now to get access to this value, we'll go to the group input. And we want to create a line using this length. I'm going to do a vector multiply because we're going to want the ends of the line to be vectors. I want the arch's length to control the length of the entire bridge. So we're going to go half the distance on one side of the origin and half the distance on the other. Control-Shift-D to duplicate. And we'll put this into a curved line. Now we have a line. I could leave well enough alone here. However, the whole process of creating a line based on an input parameter is going to happen over and over again. I would like to create a group to automate that. Let's go ahead and do that right now. It'll save time in the long run. Select those two, Control G. Now this is going to be generic, so I don't know that this is arch's length. I'll just call it value. And I also don't know if this value represents the whole length of the thing or the half the length of the thing, so it's convenient to also add a scaling factor, which defaults to 0.5. We'll multiply these together to get the total length. Now, I want to make one of these negative and one of these positive, but I also don't know if it's going to be a negative x, a negative y, or a negative z. Let's allow for every possibility. I'm going to create booleans for x, y, and z. This does two things. One, it produces a tick box on the interface that the user can check depending on whether they want x, y, z, or a combination. Also, it gives us a number between 0 and 1 that we can multiply by. So if we combine these into a vector, we multiply it, we will change this value into a vector with one or more of these values set. So this gives us our positive distance. If we scale it by -1 and multiply by that, that gives us a negative distance. I just find little things like this to be huge quality of life improvements. Tab to get back out. Go to scale of 0.5 so that the line straddles the origin on the x-axis. So we want the overall length of the bridge to be equal to this, but we want to have it centered on the origin. It just keeps everything nice. We also want to do the initial construction on the xy plane because fill curve only works in the xy plane. It took me a while to figure that out the first time through because I was doing everything on the z-axis, and then I had a bunch of backtracking to do. Anyway, it's lovely to see the future. Wish I could do it more often. The other thing I know from seeing the future is we want these to be backwards. Because we're going to create a single contiguous curve, the order at which the vertices appear is important. And I decided that everything's going to happen clockwise around the perimeter of this fancy curve we intend to create. Now the number of samples on this curve will control the number of arches on the bridge. So let's do that. And we want this to be under user control too. So by dragging this over to here, we create a new input variable. Call that arches. And I'd like to do 2 arches for the purposes of this demo. And let's put some arches on this. The instances will be an arc. I want the radius of this controllable by the user. So let's create a group input variable for that. There's another trick I use a lot, and that is just take this, drag it out into space, and let it go. And when that happens, if you bring up the group input, it'll automatically create a new input value with the name that matches this one. I want to change the name of this to something more meaningful for this project. And let's make this 0.5. And 180 degrees will be fine. Now we're cooking. One tiny glitch in this is if we have multiple arches, then everything will be nicely centered along the line. But if we want just one arch, our sample size of 1 is going to put it at the end. Well, that's terrible because we want it in the middle. So let's go ahead and take care of that now. If the number of arches is less than or equal to 1, we'll just create a line that has no length and it'll be at the middle of the bridge, and that will force our point to be there. Let's add a switch statement. So if the number of points is less than or equal to 1, we'll use our weird line. And if it is greater than 1, we'll use the line we just constructed. So you see if we have a single arch, it's on the origin. If we have more, they're spaced evenly along the line. So I've already created a way to control the arch height. But now I want to be able to independently control the width. So let's create a value for that too. Now if we divide these, we'll get a ratio between them. And if we change that into just an x coordinate, we're going to wind up scaling in the x direction. And to accomplish this, we can use the scale instances feature. Now there's just a couple of things to do. We want the arch height to control the radius. And we want the y and the z to just remain unchanged, so we'll multiply by 1, or scale by 1. Now if we've done everything right, the width controls the width, and the height controls the height. Now to give a little window into the video making process, originally this was a whole lot more nodes, as I just sort of pieced it together. And I thought, wow, that's overly complex. I took what I'd done, translated it to equations, reduced those equations, and then realized I only needed these 2 nodes in order to accomplish this independent scaling of width and height like I wanted to. It seemed unnecessary to take this video through that same process of discovery. So even though this math here is a little bit opaque and a little bit maybe oversimplified, I would rather present fewer nodes than more nodes, even if the more nodes might be clearer. Now we're going to construct the top part of the bridge. But before getting to that, I just want to give you a little heads up on where we're going. So the way this is going to work is everything I create now is going to be turned into points. And so we have the bottom of the bridge in curves, which will be translated into points. We're about to construct the top side, which is a curve or a flat, which will also be turned into points. Then we'll add just 2 more at the bottom corners to make up for the fact that the arches will never be longer than the bridge itself. And then we will take a circle of exactly as many points as we create, and we will map each point in the circle clockwise to each of the points we've created. And what that will do is it'll give us a closed polygon that perfectly captures this entire surface. And that way we can texture it at a go and wind up with a nice side of our bridge. Now, if you're coming from the modeling world and are used to thinking of everything in quads, this is terrible geometry. And if I really cared, it would be possible to go back and use raycasting to break this up into quads, vertical quads. But as long as you're careful with what textures you use on this surface, this extra complexity is unnecessary. What I did find out is all the textures I purchased from Polygon worked great on this bridge, on the side of the bridge. The free textures I got from Polyhaven generally did not, and it has to do with the way they handle displacement. Texture that makes strong use of displacement gives a really ugly surface on this N-gon. And so if you use one of those, it's really easy. You can just cut the noodle that connects up to displacement and you're fine. You just get a little bit less detail on the surface of the bridge, but otherwise the results are ghastly. The top part of the bridge is going to be a cosine curve. So the first thing I need is a curve. And we'll need a length. And this is the first time we've ever explicitly referenced the length of the bridge, so I need to create a value to hold that. And like everything else, this will be centered on the origin, so I want to start before and go after. And we're going to use that handy-dandy little group I created earlier to create this line. Shift-A, go down to groups, and I didn't give this a name, so let's do that now. We're going to alter the position of the points along this curve with a set position. And I want to resample it to gain some control over the resolution of the bridge. And I'm going to give this control to the user. Drag this out into space. And 10's good enough for now. Now we want to alter the shape of this curve with a cosine. So let's do that right now. And I know the cosine deflects downwards originally, and I want positive values to be up. Let's reflect this around 1. Now by default, a positive value that going into cosine will cause the bridge to hump up. And what we're going to do is every point along this line is going to be run through the cosine function. And we want a value between 0 and 1 or 0 and some value here. And we get that from the spline itself. That is the spline factor. Now, this value runs from 0 to 1, but we want it to run a whole iteration. We want this to run from 0 to 2 pi. And thanks to Blender, I don't have to remember what pi is. I can just enter 2 times pi in the box, and I get it. And I'm going to need 2 values right away, so I'm just going to create them now. We need a float to control the height of the hump. And we want a float to control the height of the bridge. So what we're going to do is take the x, feed it into the cosine function, take the result of the cosine function, and multiply it by the y value. So the x starts at 0, which means the output of cosine starts at 0, gradually increases, so we'll get higher values of y, and then gradually decreases, and we'll get lower values of y. And this is going to be in vector space. So I want to vector multiply. Shift D to get a copy of this. And I want the hump height to be the y value. And we'll multiply these together. And now it falls right with the world. We get our curve. Now, I don't know if you're anything like me. I did a lot of modeling and following of modeling tutorials and all the tricks with proportional dragging, and that's great for, you know, I did the anvil a couple of times. I did a few donuts. But then when I found out I could use math to generate these shapes, it was like, oh yeah, this is the way I want to work from now on. Just a couple more details before we leave this. I want this curve to start at the top of the bridge, so we want to add in the bridge height. Shift T to duplicate and change it to an add. And I want to add in the bridge height, but I want to add it in to the y value only. Shift T to duplicate. So we take this value, we multiply it by 0 in the x, 1 in the y, 0 in the z to get us our vector. And now if we give ourselves some height, nice. And we already have a variable to control the height of the hump. But to me, the shape of the top of the bridge is critical to the overall look of the bridge, and I don't want everything to be a cosine curve. So the one easy way I found to distort this to provide a variety of shapes, from a more circular shape to a more cosine shape to something completely absurd, is to run the cosine through a power function. So let's do that now. So now you can see you get a great deal of control, but I want to give this control to the user. That's nice. So what I noticed is you really don't want the exponent to get below 0.4 or so, because it starts getting really squirrely. But now we have all the control we want. So if we want a circular shape, we can do that. If we want a humpier shape, we can do that. And of course, we can make it negative or positive, however we feel like. That's better. Cool. We'll just leave it like this for now. Let's do a join geometry so we can see what's going on. So as I said before, we're going to join these points together into a single shape and then map a circle to it. But we've also done almost all the work. So for example, this top part can be divided into 2 pieces and extruded a couple of times to form the bridge rails. It can be extruded once from front to back to form the decking of the bridge. These circular shapes here not only form the bounds of our bridge sides, but we're going to extrude those a couple of times, and they're going to form the stoned archways on the bottom of our bridge. So really all the major components that define the shape of the bridge have been finished. Now it's just a question of turning them from one-dimensional lines into three-dimensional shapes. I'm going to start the big circle at these curve shapes. So the first point I need to add is a point out here to define the corner of the bridge. So I'm going to want half the length of the bridge in the negative x direction. So I'm going to take the bridge length and multiply it by minus 0.5 to get this point out here. And if I select group input and just go down to the variable we want, I can get it that way. And this is going to have this is going to be x value of this. The z is going to be 0 and the y is going to be 0. And we want to turn this into a single point. Now I learned something about join geometry in this. This little bar node here means you can connect any number of things to it. And usually you don't care. You just drag into the top and you're done. But you can also drag to the bottom and cause the nodes to cross. The question is, why would you want to do one over the other? And the answer is because the top to bottom order actually matters if you care about the order of points. And we care a lot about the order of points. So it turns out that first in is the first points. So these are going to be the first points in our combined object, and then we will add this point to it. Next, we want to add the top of the bridge. So it's the same thing. Everything we've collected up to here, up to this point, goes in first, and then the top of the bridge goes in second. Now we want a point down here. So this point here is almost exactly what we need, except we want to multiply by positive a half. We need a new join geometry. Now, in order for this to work, everything has to be points. And some of the stuff in our current geometry is curves. So let's fix that. Oop, I also notice that needs to go into the position, which means this one needs to go in the position. Sorry about that. This is instances. So we first need to realize the instances and then do a curve to points. And now let's provide a way to control the resolution of these humps so we can make them smoother or not as smooth. And we'll do the same thing to the top of the bridge. And we already have the value for this. Now we can use this as the basis to form the closed polygon. First off, let's create that polygon. Now we could do a bunch of math to figure out the points we need, but why go to all that trouble when Blender's perfectly capable of counting for us? Do an attribute statistic on the index. So this will give us our maximum index. We'll add 1 to this to get from the maximum index to the total number of points. Yes, I can leave computer programming behind me, but I cannot get away from off by 1 errors. We'll use this to drive the number of points on our circle. And these points we're going to manually place with a set position. Now, where are the points going to come from? They're going to come from this geometry. And so what we're going to do is take all the points from this complicated geometry we built, and we're going to copy them one at a time by index over to this curved circle, essentially making the curved circle follow the same path as our points. This is a 3.4 feature. If you want to do this in 3.3, you'll use the transfer attributes node. We'll need a vector because we're transferring the position, and we are transferring it by index. And if we have been very, very good, yay! And the whole point of this exercise is to get something that looks good when you fill it and you texture it. And we have accomplished that. And I like this method in general because previous methods, I would use math and long nested switch statements to put points into a curve by specific positions, and it got really ugly. And this is just so much more generic. You basically create the things you want to have as part of your shape, and you just add them in one at a time with a join geometry. And you can go back and fiddle with it. And because we use the attribute statistic to calculate the number of points on our final circle, we don't even care what happened back here by the time we get to the end. We just know that it is a clockwise or a counterclockwise path of points, and we just connect it with a circle. So we took a little break and did some cleaning up, basically tidying up the nodes and adding boxes around them, just so I could keep track of what was going on. Turn down the bridge height a little bit. That looks more right. Okay. So first of all, I want to create a value for the bridge width, which we now need. And I'm going to take this curve, fill it, and make two copies of it, one for the front face, one for the back face. I'm not sure if n-gons versus triangles makes a huge amount of difference, but I've been using n-gons. And we want the bridge width. And we'll use our values to vectors group again. Told you we get a lot of use out of this. Now we're going in the z direction. Control H to shrink that down. So one, we'll create two copies. One will go back. And the other will go forward. Control Shift D to duplicate with noodles attached. Now we have the sides of our bridge. Lovely. And we can also take this curve and use extrusion to create the deck, the bottom of the bridge, and the ends. So we will push this back and extrude it forward. And in order to extrude this, it actually needs to be a mesh. And it is edges, so. And we want it extruded along the positive z. And there we have the outline of our bridge. And I think this is a good place to stop and call this part one. So in this, we created the outline for this super swanky bridge shape. And the technical stuff I wanted to cover was the formation of this arbitrary curve. I think that's a really cool trick. I'm going to use it a lot in the future. Part two will cover how to create the arches and the rails and how to procedurally UV unwrap everything. Right now you should be seeing a link to that part two of the video on the left-hand side of the screen. On the right-hand side of the screen is a video I did prior to this showing some node groups to control textures in a project like this. And with this many surfaces and a few textures going around, and each face of each object potentially having a different scaling or rotation of a texture, that's a really handy trick. I hope you enjoyed the video. Thank you so much for watching.